Hi everyone, this is Adish Kumar from Tamil College of Engineering and Technology. Now we are going to discuss about a subject, irrigation and drainage engineering. So in this subject we have 5 units. Unit 1 has water resource and irrigation requirement. Unit 2 has irrigation methods. Unit 3 has diversion and impounding structures. Unit 4 has canal irrigation and command area development. Unit 5 agriculture drainage. So in our unit 1 water resources and irrigation requirement, first we must know about what is meant by irrigation. Irrigation is the process of applying water to the crops artificially. It is called irrigation. We are applying the water for crop water demand. The necessity of irrigation: whenever we are receiving insufficient rainfall and uneven distribution of rainfall, improvement of perennial crops, the development of agriculture in desert area. Advantages of irrigation has increased the food grain and generate the hydropower, domestic water supply, increase the prosperity of the farmers, and inland navigation, forestation. Disadvantages: there may be a chance of farming waterlogging problems, and the groundwater also polluted due to fertilizer application, and also it requires large fund. Then these are the some scopes of our irrigation. Some of the definitions in it: crop period and base period. The time elapsed between the sowing to harvesting is called crop period. The time interval between the first watering to the last watering is called base period. Then delta, it is the total depth of water required for the crops to attain its full growth. Then duty, it is defined as the ratio between the area of the crop cultivated and the quantity of water required during the entire period. The unit for delta is in depth unit. Duty for the duty unit as hectares per cubic. So this is the problem we are having, that for the relation between duty and delta is D is equal to 8.64 B divided by delta. So here D is duty, delta is delta, B is base period. In terms of days we have to substitute. This is the workout problem. Then factors affecting duty: different types of crops. Based on the crop, duty will be vary. Then climate, season, useful rainfall, types of soil, then quality of water, method of irrigation. Methods improving duty: to prepare the field before sowing, then handling the irrigation supplies. These are very important for improving the duty. Then routing characteristics: the routing characteristics is to be analyzed by this way. We are identified the soil moisture content in times of days. It will not be reach our permanent wilting point. The graph will show you the regarding information. Available soil moisture is there, field capacity is there, permanent wilting point is there. The FC is the field capacity, PWP is the permanent wilting point. See, this graph will shows the moisture content which is available will be keep on above the permanent wilting point. Whenever our soil moisture will gets reduced, it will, before reaching it to your permanent wilting point, you have to irrigate. Then evaporation is the process. We can convert the liquid into gaseous for making the hydrological circle. Then estimation, factors affecting evaporation losses. The evaporation is one of the very important parameter in our agriculture field. The factors affecting evaporation losses are nature of the evaporating surface, area of the water surface, depth of water in water body, humidity, wind velocity, temperature of air and water, atmospheric pressure, water quality of water. Then estimation of evaporation is by 4 methods: using evaporation pan, using empirical equation, water budget method, energy budget method. So this is the common method instrument which is used for finding out the pan evaporation. This is the instrument which is having a diameter of 1.225 square meters, and it has a depth of 235 mm inside this. And after that we have some space between the soil medium and pan, and it is to be monitored through thermometer for temperature, and it's also be monitored through measuring devices for the depth of water. So these are the some of specification for our pan evaporimeter. This is the actual view of the pan evaporimeter, which will be covered with wired mesh to avoid the impurities enter in this. So these are some of the empirical equations for measuring the evaporation. So this is about water budget. We can quantify that energy budget, water budget, and energy balance is the more or less same method for identifying the water quantity, which will be quantified through total quantum of available water. Then it will be having some forms. That form is to be identified. Then that quantity is to be neutralized. Based on that, we can find out how much is to be evaporation. Likewise, they will done it. The next one is transpiration is very important. Whatever the evaporation is happening in our soil surface is called evaporation loss. Some of the water is to be lost from the plant leaves, that is called transpiration loss. The transpiration loss is to be identified by indirect methods only, not directly we are not able to identify it. The evapotranspiration is combinedly identified by some of the equations, the above equations. Mostly consumptive use will be considered as transpiration loss. Then these are the methods for identifying the consumptive use water. One is tank and lesimeter, then field experimental plots, oil moisture studies, integration methods, flow, inflow and outflow studies for large area. You see, these are having some indirect methods: Bundley-Griddle method, Hardy-Cross method, then Penniman's equation. Then effective rainfall. Whatever the precipitation is during the period of crop, that will be called as effective rainfall. That effective rainfall is to be utilized, useful for precipitate crop growth. That's why it is called effective rainfall. In sometimes we are receiving the rain-fed water that will not be utilized for crop growth. That is not to be an effective rainfall. Factors affecting rainfall. One is rainfall characteristics, then land slope. Here rainfall characteristics as the intensity of rainfall, then characteristics of soil, groundwater contribution, management practice, crops. The determination of irrigation requirements for crop, then rainfall, effective rainfall, consumed irrigation requirement, net irrigation requirement, field irrigation requirement, grass irrigation requirement. These are irrigation requirements of crops. Effective rainfall is amount of rainfall received from the precipitation during the crop period. Then consumptive use, that amount of water is to be evaporated from the plant leaves, that is called consumptive use. Then net irrigation requirement, the amount of water required to meet the evapotranspiration needs as well as other needs is called net irrigation requirement. Field irrigation requirement, it includes the conveyance loss and other evaporation losses too. This is the amount of water required to meet the net irrigation requirements plus water lost in the field. Then gross irrigation requirement, it is the sum of water required to satisfy the field irrigation requirement and lost during the conveyance losses. Then intensity of irrigation, we are irrigating the field with water, that percentage of culturable command area to the proposed irrigated during the crop season is called intensity of irrigation. Then paleo irrigation, core watering. Paleo irrigation is the application of water to the dry land which showing the crop is much difficult, in order to moisten the soil so as to help us sowing the crop. So core watering is used to describe the water given to the crop when the plants are still young. Here paleo irrigation is utilized for ploughing the lands. Core watering is utilized for nurturing period. Then irrigation efficiency, conveyance efficiency, water delivered to the field divided by water delivered from the reservoir. It is called conveyance loss. Then water application efficiency. Water stored in the root zone during irrigation divided by the water delivered in the farm. Then water storage efficiency. Water stored in the root zone during irrigation divided by water needed in the root zone prior to the irrigation. Then water use efficiency. Water used consumptively divided by water delivered in the farm. Then uniformity coefficient or water distribution efficiency is equal to 1 minus y divided by d. That is, y is average numerical deviation in the depth of water stored from the average depth of water stored during irrigation. D is depth of water stored during irrigation. So apart from this, we have water resources in our world. 2/3 part will be covered with water, so out of which most of the part will be in saline water. So some quantum only in fresh water. It is to be available in groundwater as well as surface water as well as ice cubes, out of which groundwater will be very very less and surface water will be also again very very less quantity. So if you are coming to Indian scenario, we have 12 river basins are there. So out of which 12 major river basins are there, out of which we have n number of small river basins also included in that maximum watersheds. Okay, this is our unit 1. Thank you.